We have a test on Monday. Yeah, all right. So, today is a fairly easy day. It is mostly review, but hopefully it'll sort of set up, firm up some ideas that we've been trying to put together about similar triangles. And you should have plenty of time to get the assignment done today and maybe work on anything that else needs finishing as well. So use your time wisely today. You are going to see the very same pictures in your assignment today as we have here in notes, and the numbers will be different, so please don't use the same answers. You can expect the numbers to be different. The pictures will match, though, which is kind of nice. And I summarized a bunch of this to simplify just what are we trying to find. When you see it in Delta Math, there's going to be a whole lot of words to read, but I boiled it down to the nitty-gritty important stuff. So on this number one, we want to find the distance UV from U to V across the lake. If I don't know what this distance is, what should I call it? X, sure, let's call it X. Oh, you can't really see that, can you? Here, let me try pink. Maybe pink will work better. So there's our distance X across the lake. Now, how many triangles do you see? 2 triangles, yes, only 2. I have a baby triangle right here, and we have the giant triangle. So when we're setting up our proportion here, Jojo, we need to think of the baby triangle and the giant triangle information. So I'm going to start with the baby, because the baby's easy to see. I have the top of the triangle, so I'm going to call that 180 meters. Over the left side here of the triangle, 147.6 meters. So I did top over left. I need to do the same pattern in the giant triangle. What's the top of the giant triangle? 250. How did we get 250?
Combine the sides.
Combine those 2 sides. 70 plus 180 gives us the whole side of that triangle. Can we use 70? No, because 70 is just a tiny, tiny segment. It's not the whole side of a triangle, so we can't use that. We're going to use the whole top of the big triangle and the whole left side of the big triangle. So we've got this little pattern going. We've got top over left in the little and top over left in the big. And that's how we set up a proportion. Okay, what do we do to solve for x? Cross multiply. We're going to do that. 180 times x is 180x. And 147.6 times 250 is 36,900. And then what do you need to do? Divide by 180, divide by 180, and we get 205. What are the units?
Meters.
Meters. Very good. Everything is meters. The units for the distance across the pond is meters as well.
Wait, would it be meters?
It is not, because it is a length. So this would be like 300 feet or 300 meters or 1 mile.
Meters squared, because the 250 times 200,
but we're not
250 mile are meters, like you're combining the meters
so
and square, wouldn't they?
You are not wrong. So what's happening here is we have meters times meters, so we get 180 meters squared. And over here we have more meters squared, so whatever meters squared. And then when we divide by the 180 meters, we're dividing by 180 meters. A meter squared and a meters cancels out.
Okay.
And we're still left with meters.
Okay.
Okay? So I love that you're analyzing the units. That's very cool. But yes, length is meters. Okay, let's look at number 2. On number 2, the paragraph reads that kicker on the football team has placed a mirror. And so there's this mirror, a little mirror on the ground. And he is looking into the mirror and sighting the top of the goalpost. And it's something we could actually do in real life to find the heights of things. And it is sort of what surveyors do in real life to survey the land and find elevations and stuff like that. So what we've got here is we've got some triangles. And I have the triangle with the height of the guy. He is perpendicular to the ground. And I have this goalpost, and I'm just going to, again, we got to see triangles here. And again, we're hoping that that goalpost is straight up and perpendicular to the ground. And our job here is we want to find the height of the goalpost. So I want to figure out the height of the goalpost, and I don't know what it is. What should I call it?
X.
X, sure. We don't know. We're going to call it X. Okay. Now, but before I do any more, I want to make sure, are these triangles similar?
Yes,
Why?
because they're both right.
Okay, that's one angle, so they have an angle in common. So they got a pair of congruent angles, but we need another angle that's got to be in common. The middle, in and out. Yeah, this angle right here, what that is it's called the angle of incidence and the angle of reflection. In physics, the angle of incidence is exactly equal to the angle of reflection. When you have a mirror, the angle coming in just reflects exactly away. And so they are congruent. These two triangles have angle-angle similarity, and so we can set up a little proportion. So I'm going to look at my baby triangle here. I'm going to do the height of the dude, 1.75, over his distance to the mirror, so 1.25, equals what over what? Height of the goalpost over distance to the mirror, 12.35. So again, we just got that same pattern. Height over distance is equal to height over distance. And you can set that up pretty easily. And then we need to do what?
Divide. Or wait.
Cross,
Multiply.
cross, multiply. All right, so we get 1.25 times x equals 1.75 times 12.35, which is
21.61.
21.6125. Make sure you keep all the decimals. Don't round anything off. Keep everything. Then we're going to divide by 1.25. So we get x equals 17.29. Now, it says to round to the nearest hundredths of a meter. Hundredths means 2 decimal places. So we want the 2 decimal places. Okay, that position is to the hundredths. All right, so keep it 17.29. There was nothing after that 9, right? It stopped?
Yeah.
Okay, good. So there we go. So this is meters, 17.29 meters. All right, questions on either of those? Okay. Doing lots of cross multiplying, aren't we? Yeah. All right, number 3. Find the height of the tree. So here's our tree, and we want to know the height of it. And so I don't know the height. What am I going to call it? X, sure. Okay. Now, I want to give you some more information about this picture. What's happening here is the sun, Mr. Sun. Mr. Sun is right here, shining down. And what does the sun do when the sun is out, like this gorgeous day today? Yeah. We get a shadow, casts a shadow, right? So we've got the sun rays coming down. They're being blocked by a tree, and then that shadow gets laid on the ground. So what I'm looking at here is we have these shadows. This is the long shadow of the tree. And then our dude standing up there, and we're also seeing his shadow. So his shadow is laying down right here as well. And so the top of his head is lining up with the very top of the tree. All right? And that is something you could really do in real life. So again, I want to know, are the 2 triangles, are they similar?
Yes.
So they have 2 right angles because we're assuming they're straight up and down. Where's the second angle that they have in common? Angle.
No, it's a 41.35, but
Follow it right here.
yeah.
The angle, not a length. Angle. So they both have this overlapping angle here. So we got a pair of angles that match. So that's angle-angle similarity. Okay, I have an orange triangle right here. How long is the dude's shadow?
4.45.
How'd you get 4.45?
41.35 minus 36.9.
Good. 41.35 minus 36.9. We need to know the length of the shadow. 4.45 meters is the length of the shadow. Good. So now I can set up my shadow over my height. Sure. 4.45 over the height of the dude, 1.75. All right, so I got the shadow over the height. Now look at the big triangle. What should I write for the big triangle?
41.35 over x.
41.35, so that's the height, the length of the shadow of the tree over the height of the tree, which is just x. All right, how do you solve? We don't need to cross multiply. I'll just give you the answer. We are going to cross multiply, so 4.45x equals yada, yada, yada. Now, when you solve for x, what did you get? 16 point. Nobody did it. We'll let you all off the hook. 2612 ... went on for a while. We want to round to the nearest hundredth of a meter. Hundredth of a meter. Yep, so hundredths means we need 2 decimal places. So we keep the 26. We have to look to the neighbor to the right. You actually have to look to the thousands place. And if that 1 was like a 5, then we'd round 26 to a 27. But this one's going to stay. 16.26. Okay. Meters, yes. 16.26 meters. Fantastic. Any questions on that one? Okay. Last one, which is a little bit different. So okay. We want to find PR, the distance across the river. So I don't know what that is. I'm going to call it X. Oh, you probably can't see that. Not too well. All right, so we have this X here that I want to figure out, the distance across the river.
Wouldn't it just be like 135 plus x over 300?
We are going to do that, yeah. So again, we have a common angle here up here at angle P. So they do have angle similarity, couple of angles. Now I got a baby triangle. I'm going to set it up x over 185. So that's the left side over the base. What should we do for the big triangle? Yes, 135 plus x. The whole side length there is x plus 135. Piece plus piece. So the whole left side would be x plus 135 over the entire base, which is 335. And we just need to make sure that we distribute very carefully on this problem. I have 335 times x equals 185 times the quantity x plus 135. What do I need to do with that 185? Distribute. Very good. Thank you. So I have 335x equals 185 times x is 185x. What's 185 times 135?
24,975.
24,975. Beautiful. And then we need to good, minus 185x, which is
166.5. Or wait, that's the answer.
well, that's the answer. 150x's equals 24,975. And then we need to
Divide by both sides.
divide by 150.
150.
We get x equals 166.5. But they want us to round to the nearest foot, the nearest whole feet, which would be what?
167.
167 feet, whole feet, no decimals. All right. Do you have any questions for me? All right. You should have time to do all of this assignment. No problem. You can use the back side of the paper. That would be great. Please ask questions if you got them.